Hello. Today we'll discuss about a topic why common collector amplifier is called as emitter follower. Why common collector amplifier is also called as emitter follower. We'll see the details now. This is a simple common collector configuration. Any transistor, if it wants to act as amplifier, it must be in active region. So to keep a transistor in active region, we require biasing. The biasing for this transistor is provided with the help of VCC, R1, R2, RC and RE. These four resistors along with VCC is providing the required bias for this transistor so that it will be in active region. Now it is ready to amplify the small signals whatever applied across its input. So this V input, which is indicated as a sinusoidal signal, it is actual input signal, that is small signal, which we are applying towards the input of this transistor so that it will be gets amplified. And a transistor can be configured either in common base or common emitter or common collector based on the terminal which is common for both input side and output side. If you are looking for this configuration, look at this one. Output we are taking across emitter. The arrow always implies it is emitter. So output we are taking across emitter towards ground. So this is V0 output, and input we are applying across the base. The other terminal is collector, which is considered as ground. But if you are looking at this diagram, collector is connected towards plus VCC. It is not at ground. But actually with respect to AC terms, the collector is connected towards ground. Why? Now if you observe this circuit diagram, it consisting of two sources. One is AC voltage source, that is V input, the other is DC voltage source plus VCC. So if you want to know the total response at that time, the total response is due to both voltage sources. But using superposition theorem, we can calculate output voltage due to one voltage source by keeping the other at 0. The same thing is going to be also true. If you are calculating output voltage by keeping the DC voltage source at ground, by that time the analysis is called as AC analysis. AC analysis means what we are considering as input is AC signal, and all other voltages like DC voltages, constant voltage drops and all other things are going to be treated as ground. So what you are going to be getting at the output, that is nothing but AC response of this amplifier circuit for the given AC signal. So for AC analysis, the DC voltage source and other constant voltage drops will be neglected, that is will be considered as 0 voltages. So by that time for AC analysis, this VCC will be treated as ground. In that case, collector is going to be connecting towards ground and it is act as common terminal for both output side and for input side. So the input signal, whenever you are applying input signal is AC signal, that AC signal is going to be applying towards input of this transistor. So AC signal means it's going to be a frequency sensitive signal. For the lowest possible frequency of input signal also, we assume the capacitor act as short circuit. This capacitor is called as coupling capacitor, which couples the input signal towards input of transistor. Otherwise it may be coupling the output of previous stage towards input of this stage. That's why the name has come as coupling capacitor. Now so if it is acting as short circuit, what input is applying is nothing but towards directly base. Base is connected with V input. So now we will see why it is called as emitter follower. Look at this diagram. This diagram is a part of this entire circuit. So simply V input is going to be directly connecting across base, and voltage drop across base and emitter is indicated as VBE, and voltage drop across RE is nothing but V0. V0 is nothing but current flowing through RE into RE. Current flowing through RE is IE. voltage drop across RE, that is nothing but IERE, is going to be treated as V0. From this one we are concluding common collector can be act as emitter follower. Apply KVL across base emitter loop. So KVL across base emitter loop is nothing but this is the loop. Apply KVL plus V input minus VBE minus V0 is equal to 0, and you can write it as V input is equal to V0 plus VBE. VBE is nothing but voltage across base to emitter, which is nothing but generally emitter base junction. That emitter base junction is normally forward biased for active region. So VBE will be at most equal to 0.7 volts for silicon transistor. So we can write the above equation as V input is equal to V0 plus 0.7. This 0.7 is going to be treated as constant, so that V input is proportional to V0. In other words, in terms of AC analysis, V input is V0 plus 0.7, but 0.7 is going to be a constant term that can be neglected for the AC analysis, so that V0 is equal to V input. Since V0 is equal to V input, that is V0 is nothing but emitter voltage, V input is nothing but base voltage. Observe this diagram. V0 is nothing but voltage across emitter, V input voltage across base. That is V0 is equal to V input is nothing but emitter voltage is equal to base voltage. So whatever the base voltage you will apply, that will be equal to the emitter voltage. So emitter voltage acts as a follower of base voltage. That's why the name has come as emitter follower. So voltage gain for this one is nothing but output voltage by input voltage. V0 divided by V input is nothing but voltage gain of common collector. Since both are approximately equal, voltage gain of common collector is also 1, that is unity. Common collector has ideally unity voltage gain, practically smaller than 1 because of this 0.7. So V input is greater than V0 by 0.7 volts. So that voltage gain practically nearly unity, ideally unity voltage gain for the common collector. Since emitter voltage is following the base voltage, the name has come as emitter follower. Thank you.